Everyone, so we are now looking at Demorgans rule type 2. We want to prove the type 2, which says that B intersection of C complement should be equal to B complement union of C complement. So the first step we have done type 1, then type 2 we are going to let our x be equal to, so we are moving from the left hand side, the left hand side is this side, to the right hand side. So our right hand side is this, so we want to move from here to there. So we are going to let our x be a member of whatever set is here. So we are going to say B intersection of C complement, like that. Then after that, what we are going to say is, since our B intersection of C complement, so get the picture of this. So this is your B, this is your C, like that. So already this is your B, this is your C. So already if they are saying that X is an element of B intersection C complement, let's say this is the complement part of the set, it means to say X is somewhere here. Now what B, this means that the separate set of our B and C, X is not found in B and C, in the intersection of B and C, X is not there. So this means that you will say that your X is not a member of B intersection C, since this is the set for B intersection C. It is only found in B complement in the section of C complement. So if we do that, or B intersection C complement, if we do that, what we are going to have is more like saying our X is not a member of B, then or X is not a member of C. So I have skipped one line for a purpose. So now you get to understand to say and means intersection. So some of your lecturers may want you to show the and, others may not want you to show the and just go direct. So you must know your lecture. So what we are going to say is that here, let's account for the ands to say X is not a member of B and X is not a member of C. So this in yellow is just implying to say this depends on your lecturer. Some of your lecturers may just want you to go direct like that. Now we are able to do this because if X is not a member of B, so this is the B, if X is not a member of B and X is not a member of C at the intersection of these, it is not found in here. This means that already your X must not also be part of the union, or means union. X cannot be a member of here if it is not found there. So that is how we go about that one. So now considering that, we are going to say that our X must be a member of B complement, or X must be a member of C complement. If it's not found in B, it means it's found in B complement. If it's not found in C, it means it's in C complement. That is what we mean by that. Now remember, already we have our X, what we are going to just say that X must be a member of, so we are just going to combine. It's more like we are factorizing. X is common, E is common, then we are going to say B complement, or means union of C complement, like that. So this means that we moved from B intersection of C complement to, so we are going to use the subset, meaning to say B intersection of C is contained or is found inside B union of C complement, like that. So now we have moved from this to this. Now we need to move backwards from this to this. So what we are going to begin to do is conversely, we have our B taking the right hand side, going to the left hand side. So we are going to have our B complement, union of C complement, like that. So how do we move about that? We are going to let our X be a member of the same set, which is our B complement union of C. So what this entails is that X is a member of B complement, then we have, and also we have our X. We can say union means or, so we can say or X is a member of C complement. Now this means that your X must not be a member of B. So if it is not found in B complement, or if X is found in B complement, so this is what we have. We have our B, we have our C. So B complement, like that. Then we have, let's say, our actual sets B and C. If it is found in B complement, meaning to say, let's say X is found in here, B complement and C complement. Here there is no X. It means to say X is not found inside B. So we are going to say X is not a member of B. Then we can say that, or your X is not found inside C. Since it is found in C complement, it is not there in C. That's the implication. So now, if already or means in that union, meaning to say the whole of this set. So if it is not found inside the combination of B and C, it means to say it is not also found in the intersection of B and C. If it's not there in B union of C, union means the whole of these sets. If it's not there in the union, it is not also found in the intersection. So I'll leave a space. So this means that your X is not found inside your B intersection of C. So now, for the sake of some of your lecturers, they would want you to put this. If it is not found in this all changes to and you are going to say X is not a member of B and X is not a member of C. So this again just depends with how your lecturer is. Some might want to skip this, some might want you to write this. So you just have to study your lecturer. This is the only difference. So we are going to say that our X now must be a member. Our X must be a member of B intersection of C. Then we are going to put the complement outside. So if this is if this is not a member, then the complement of this same set means to say that's your room. So now let's compare the two sides. So this, what it means is that firstly, you just need to know how to prove one side. So if X is a member of this, let's say you move like that. So you will realize to say the first step here. So we have the first step here. The first step here is the second last step. Okay, first we began with this, which is this. So that's the first one, which was the last one for this one. Then we have the B intersection C as our second last. We move to here. We moved to here and all that. So now, what am I trying to communicate? So all you have to know is you have to just know how to prove one side. So if you know how to prove one side, let's say you prove this side. So what you just begin to do is your second point, which was this one, becomes your first point. You go to here, you go to there. You go to here, you go to there. Then you have this stage. So it's more like you have just proven one side. Then upon proving one side, then you just start copying backwards. Thank you very much for watching. Hope you would like, subscribe and share for more.